Hey everyone, welcome. Today we're going to break down the code you write into its absolute smallest, most essential parts. We're talking about the fundamental building blocks of any Java program.
Okay, so to get started, let's ask a pretty simple question. When a computer looks at your Java code, what are the absolute smallest pieces it can possibly recognize? What are the atoms of your program? And the answer is tokens. Yep, just like atoms are the building blocks of all matter, tokens are the building blocks of your code. They are the most basic individual little units that the Java compiler can even understand.
Now here's the best way to think about it, and this is the key analogy for today. Tokens are like the words in a sentence. If you get the words wrong or the grammar is all messed up, the sentence makes no sense, right? Well, it's exactly the same for the compiler.
Here's the cool part. Every single token in the entire Java language falls into one of these 5 categories. That's it. So if you want to really understand code, you've got to understand these 5 groups. Let's break them down. First up, we've got keywords. You can think of these as special reserved words that have a very specific, unchangeable meaning in the Java language. They're like the VIPs.
The most important thing to remember here is that these words are locked. The compiler has a special purpose for them. For instance, true and false are reserved just for conditions. And because of that, you can't, under any circumstances, use them as names for your own variables or methods.
Okay, next up, let's see how this all builds with identifiers and literals. These 2 types of tokens really work together as a team to handle all the data in your program.
So here's the crucial difference. The identifier is like the label you put on a box. It's the name you give to a storage location in the computer's memory. The literal, on the other hand, is the actual thing you put inside that box, the fixed, constant value.
In this image, it just visualizes that relationship perfectly. You see the literal value, the number 23, being put into a memory location. The identifier is just the name that points to that spot, while the literal is the actual data living there.
Oh, and here's a pretty cool fun fact about that data. Java uses something called Unicode. It's a 16-bit system which gives it over 65,000 possible characters. And that is why Java is so good at handling different languages and symbols from all over the world.
All right, so we've covered the words and the data. Now let's talk about the symbols that give our code structure and make it actually do things. These are the punctuators and the operators. You can honestly just think of these as the grammar of the Java language. Just like a period ends a sentence in English, a semicolon terminates a statement in Java. And those curly braces, they group lines of code together, basically telling the compiler, hey, all this stuff belongs together.
And then we have operators. If punctuators are the grammar, operators are the verbs. They're the action words of your code. They take values, which are called operands, and they perform an operation like adding them or comparing them to get a result. They make stuff happen.
Okay, theory time is over. We've seen all 5 types, right? So let's put it all together and actually deconstruct a real single line of Java code to see every single token in its natural habitat.
So here it is. Int num equals 100. Looks super simple, doesn't it? But believe it or not, there are 5 distinct tokens packed into this one little line.
First up, we see int. That's our keyword. It's a reserved word, and it's telling the Java compiler, hey, get ready. We're about to create a variable that's going to hold a whole number. Right after that, you see num. That's the identifier. It's the unique, human-readable name we decided to give to that little spot in memory where we're going to store our number. We could have called it my number or value. That's up to us.
Then we have the equal sign. That is our operator. And it's not saying is equal to, it's the assignment operator. Its only job is to take the value on the right and assign it or put it into the variable on the left. It's the action.
So what about the 100? That, my friends, is the literal. It's not a name, it's not an action, it is the actual fixed data value that we want to store.
And finally, to wrap it all up, we've got that semicolon. That's the punctuator. It acts just like a period at the end of a sentence, telling the compiler, okay, this instruction is totally finished, you can move on to the next one now.
So, why does any of this actually matter? Well, here's the big takeaway. Understanding tokens is your first step to debugging code. When you get a syntax error, the compiler is basically yelling at you that it can't understand your sentence. And more often than not, it's because a token is in the wrong place, or, and this is a classic, you've just forgotten a punctuator like a semicolon.
So from now on, I want you to remember this. If your code isn't working, don't just see a jumble of characters on the screen. See the tokens. Check your words and check your grammar. Is every keyword right? Is every statement terminated? Thinking like a compiler, thinking in tokens, is the absolute key to writing code that actually works.